Hi guys, so in today's video we're going to talk about instantaneous rates of change. Here we have a graph of position x versus time t. And what I've shown in blue is the average rate of change of position over the entire graph. What this means is that if the particle or object, whatever it is we're considering, had travelled at a constant speed, represented by the slope of the blue line, it would have reached the final position in the time taken. However, the orange line shows us that this wasn't actually the case. It was obviously travelling at a much greater speed at first because its position was changing very, very quickly in a short space of time. It's then reached a point where it's actually stopped and turned around because the slope becomes negative. Average rate of change is always determined as the gradient of the straight line between 2 points. But what we want to ask today is, how do I work out exactly how fast the object was going at this point? And that is equivalent of asking the question, what is the gradient of the tangent at that point? And the tangent is a line drawn so that it only touches a curve at a single point. And at that point where it touches, it has to have exactly the same slope as the curve at that position. To reiterate that point, the instantaneous rate of change of a function at a point is given by the gradient of a tangent line drawn at that point. Once we've drawn our tangent line, we can take any 2 points on that line, which will have coordinates x1, y1, and x2, y2, and we can simply calculate the gradient. And this will give us our instantaneous rate of change. In order to proceed further, we're going to need to cover a little bit of terminology. As we've already seen, a tangent is a line that touches a curve but does not cross it at that point. A secant is a line that intersects a curve at 2 points. And finally, a chord is the straight line segment joining 2 points on a curve. Here we've shown a chord between 2 points on a curve. If we extend that line out, it then becomes a secant. Finally, we can also show a tangent at a particular point. If we consider a particular point on the curve, as shown here, we can have either a secant around the point, a secant below the point, or a secant above the point. The last point I'll make is actually really important, and that's that a secant that is drawn through 2 very close points on a curve will come to approximate a tangent line.